Ad hoc wireless internet. What is ad hoc wireless internet? The ad hoc wireless internet extends the services of the internet to the end user over an ad hoc wireless network. Some of the applications of the ad hoc wireless internet are wireless mesh networks, provisioning of temporary internet services to major conference venues, sports venues, temporary military settlements, battlefield, and broadband internet services in rural regions. A schematic diagram of the ad hoc wireless internet is shown below, where ad hoc network is connected with internet, iPad, PC, PDA, and maybe other such devices. The major issues to be considered for a successful ad hoc wireless internet are the following. First is the gateways, address mobility, routing, transport layer protocol. Gateways. Gateway nodes in the ad hoc wireless internet are the entry points to the wired internet. The major part of the service provisioning lies with the gateway nodes, generally owned and operated by the service provider. Gateways perform the following tasks: keeping track of the end users, bandwidth management, load balancing, traffic shaping, packet filtering, bandwidth fairness and address services and location discovery. Address mobility. Similar to the mobile, the ad hoc wireless internet also faces the challenges of address mobility. This problem is worse here as the nodes operate over multiple wireless hop solutions such as mobile IP can provide temporary alternatives for this. Routing. Routing is a major problem in the ad hoc wireless network due to the dynamic topological changes, the presence of gateways, multi-hop relaying, and the hybrid character of the network. Transport layer protocol. Even though several solutions for the transport layer protocol exist for ad hoc wireless network, unlike other layers, the choice lies in favor of TCP's extensions proposed for ad hoc wireless network. Some of the application of ad hoc wireless internet are wireless mesh network, provisioning of temporary internet services to major conference venues, sport venues, temporary military settlements, battlefield, broadband internet service in rural region. The major issues to be considered for a successful ad hoc wireless internet are the following. First, gateway. They are the entry points to the wired internet, generally owned and operated by service provider. They perform the following tasks: keep track of end user, bandwidth management, load balancing, traffic shaping, packet filtering, width fairness, and address service and location discovery. Address mobility. This problem is worse here as the nodes operate over multiple wireless hop. Solutions such as mobile IP can provide temporary alternative. The third is routing, which we've already seen. It is a major problem in ad hoc wireless network due to the dynamic topological changes, the presence of gateway, multi-hop relaying, and the hybrid character of the network. Possible solution is to use separate routing protocol for the wireless part of the ad hoc wireless network. Transport layer protocol. Several factors are to be considered here, the major one being the state maintenance overhead at the gateway nodes. Then comes load balancing. They are essential to distribute the load so as to avoid the situation where the gateway nodes become bottleneck nodes. Pricing, billing. Since internet bandwidth is expensive, it becomes very important to introduce pricing billing strategies for the ad hoc wireless internet. Provisioning of security. Security is a prime concern since the end user can utilize the ad hoc wireless internet infrastructure to make e-commerce transactions. QoS support. With the widespread use of voice over IP, VoIP, and growing multimedia application over the internet, provisioning of QoS support in the ad hoc wireless internet becomes a very important issue. Services address and location discovery. Service discovery refers to the activity of discovering or identifying the party which provides service or resources. Address discovery refers to the services such as those provided by address resolution protocol or domain name service operating within the wireless domain. Location discovery refers to the different activities such as detecting the location of a particular mobile node in a network or detecting the geographical location of the nodes. Routing protocol for ad hoc wireless network. Routing is the exchange of information from one station of network to the other, and protocol is a set of standard or rules to exchange data between two devices. An ad hoc routing protocol is a convention or standard that controls how nodes decide which way to route packets between computing devices in a mobile ad hoc network. An ad hoc wireless network consists of a set of mobile nodes that are connected by wireless link. The network topology, that is the physical connectivity of the communication network, in such a network may keep changing randomly. Routing protocols that provide a path to be followed by data packets from a source node to a destination node used in traditional wired network cannot be directly applied in ad hoc wireless network due to their highly dynamic topology, absence of established infrastructure for centralized administration, for example, base station or access point, bandwidth constrained wireless links, and resource energy constrained nodes. Issues in designing a routing protocol for ad hoc wireless network. The major challenges that a routing protocol designed for ad hoc wireless network faces are mobility of nodes, bandwidth constraint, error-prone channel state, hidden terminal problem, exposed terminal problems, resource constraint. Let's see one by one. Mobility. Network topology is highly dynamic due to movement of nodes, hence an ongoing session suffers frequent path break. Disruption occurs due to the movement of either intermediate nodes in the path or the end nodes. Wired network routing protocols cannot be used in ad hoc wireless network because the nodes are not stationary and the convergence is very slowly in wired network. Mobility of nodes results in frequently changing network topologies. Routing protocol for ad hoc wireless network must be able to perform efficient and effective mobility management. The second is the bandwidth constraint. Abundant bandwidth is available in wired network due to the advent of fiber optics and due to the exploitation of wavelength division multiplexing technologies. In a wireless network, the radio band is limited and hence the data rate it can offer are much less than that a wired network can offer. This requires that the routing protocols use the bandwidth optimally by keeping the overhead as low as possible. The limited bandwidth availability also imposes a constraint on routing protocol in maintaining the topological information. The third is the error-prone shared broadcast radio channel. The broadcast nature of the radio channel poses a unique challenge in ad hoc wireless network. The wireless links have time-varying characteristics in terms of link capacity and link error probability. This requires that the ad hoc wireless network routing protocol interact with the MAC layer to find alternate routes through better quality link. Transmission in ad hoc wireless networks results in collision of data and control packets. Therefore, it is required that ad hoc wireless network routing protocols find paths with less congestion. Fourth is the hidden terminal problem. The hidden terminal problem refers to the collision of packets at a receiving node due to the simultaneous transmission of those nodes that are not within the direct transmission range of the receiver but are within the transmission range of the receiver. Collision occurs when both nodes transmit packet at the same time without knowing about the transmission of each other. Then is the hidden terminal problem. Here, if both node A and C transmit to B at the same time, their packet collide at node B. This is due to the fact that both node A and C are hidden from each other as they are not within the direct transmission range of each other and hence do not know about the presence of each other. So this is the hidden terminal problem. Solution for hidden terminal problem is given here. Solution for this problem is given in the figure that includes medium access collision avoidance, MACA. Here we see there are two networks and there are three nodes A, B and C, and range of the two networks are given. Transmitting node first explicitly notifies all potential hidden nodes about the forthcoming transmission by means of two-way handshake control protocol called RTS-CTS protocol exchange. This may not solve the problem completely, but it reduces the probability of collisions. Next is the exposed terminal problem. The exposed terminal problem refers to the inability of the node which is blocked due to transmission by a nearby transmitted node to transmit to another node. For example, consider the figure. Here, if a transmission from node B to node A is already in progress, node C cannot transmit to node D, as it concludes that its neighbor node B is in transmitting mode and hence should not interfere with the ongoing transmission. Thus, reusability of the radio spectrum is affected. Solution for the exposed terminal problem is seen here. In this case, a node A did not successfully transmit the CTS originated by the node R and hence assumes that there is no ongoing transmission in the neighborhood. Since node A is hidden from node T, any attempt to originate its own RTS would result in collision of ongoing transmission between node T and R. Two essential and limited resources are battery life and processing power. Devices used in ad hoc wireless network require portability and hence also have size and weight constraint along with the restrictions on the power source. Increasing the battery power and processing ability makes the node bulky and less portable. Let's see the characteristics of an ideal routing protocol of ad hoc wireless network. A routing protocol for ad hoc wireless network should have the following characteristics. It must be fully distributed as centralized routing involves high control overhead and hence is not scalable. It must be adaptive to frequent topology changes caused by the mobility of nodes. Route computation and maintenance must involve a minimum number of nodes. Each node in the network must have quick access to routes, that is, minimum connection setup time is desired. It must be localized as global state maintenance involves a huge state propagation control overhead. It must be loop-free and free from state routes. The number of packet collision must be kept to a minimum by limiting the number of broadcasts made by each node. The transmission should be reliable to reduce message loss and to prevent the occurrence of state routes. It must converge to optimal routes once the network topology becomes stable. The convergence must be quick. It must optimally use scarce resources such as bandwidth, computing power, memory, and battery power. Every node in the network should try to restore information regarding the stable local topology only. Changes in remote parts of the network must not cause updates in the topology information maintained by the node. It should be able to provide a certain level of quality of service as demanded by the application and should also offer support for time-sensitive traffic. So these are the characteristics of ideal routing protocol for ad hoc wireless network.